How's it going, guys? Today in this video, we're going to be going over 2.3, day 2, where we're going to be talking about solving absolute value inequalities with applications. And that's just a really nice way of saying we're going to be doing word problems with absolute value inequalities. So absolute value inequalities are often used to model real-world situations involving a margin of error or tolerance. Tolerance is the allowed amount of variation in a quantity. And we're going to write an absolute value inequality like this. The absolute value of x minus the goal will be less than or equal to the tolerance, or the absolute value of x minus what you want, the desired outcome, is less than or equal to the error. Both these equations are the exact same. We just have different words to account for different situations, but they're the exact same equation. They're the exact same equation. All right. So let's go ahead and do an example so we can see what we're doing. On number 1, we're told a machine at a lumber mill cuts boards that are 3 1/4 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. We're going to write an absolute value inequality to represent the situation. Distance cannot be negative, and we say that because that's why we have that goal, because it's always going to be positive. All right. The absolute value there makes everything positive. That's why we have it when it comes to these types of inequalities. So let's go ahead and make our inequality. So we have the absolute value of x minus our goal or our desired outcome. We want boards to be 3 1/4 meters long. So we're going to say x minus that 3 1/4, close the absolute value. That's going to be less than or equal to our tolerance or our error, right? And we're told we can have an error up to 0.02 meters. And that means 0.02 meters too big or 0.02 meters too small. All right. And if you think about that statement a little bit, I'm sure you can solve this problem out without even having to go through the absolute value inequalities, because honestly, you guys have been doing this since you were kids, and you'll see in the next few examples how kind of really intuitive this really is. All right. It's just that this is math, and in math, you have to have stuff proved exactly right. So it looks a lot more complicated than it actually really is. So we have our absolute value inequality here. The absolute value is isolated. That's the most important part right now. We can't do anything unless it's isolated, but it is. So we can make our two different cases. A positive case, so x minus 3.25 is less than or equal to 0, or 0.02, sorry. And the negative case, where it's the negative of everything inside the absolute value. So negative of x minus 3.25 is less than or equal to 0.02. I'm going to solve the positive side first. So I'm just going to add 3.25 or 3 1/4 to both sides to get the x is less than or equal to 3.27. And I'm done there. The x is isolated. I have what x is going to be, less than or equal to 3.27. For the negative side, I'm going to distribute out that -1. To get negative x plus 3.25 is less than or equal to 0.02. And then from there, I'm going to isolate the x, so minus 3.25 on both sides. To get negative x is less than or equal to negative 3.23, or x is greater than or equal to positive 3.23. So what these two inequalities are saying, it's saying that our x, or our length of our board, has to be less than 3.27 meters, and it also has to be greater than 3.23 meters. It has to be both. So that's how we're going to write our inequality. The length of our board has to be greater than or equal to 3.23 and less than or equal to 3.27. Or in other words, our acceptable lengths, that will be from anything from 3.23 all the way to 3.27, right? And now if we forget about the math for a second and just kind of look at the problem by itself, it's telling us that we, at a lumber mill, we're making boards that are 3.25 meters long. And we're told we are not going to accept any boards that are more than 0.02 meters away from that 3.25. So either 3.25 meters more than that, or sorry, either 0.02 meters more than 3.25 or 0.02 meters less than that 3.25. And that's where we get the 3.23 and the 3.27. And we could have actually figured this out without the absolute values, but on a quiz or test, you have to put it like this because this is the proper way to do it in math. All right, it seems really unnecessary, but that's how it is. That's what you need to know, and that's how you're supposed. That's how. If we decide to give you a problem like this is how we would quiz or test it. All right, so go ahead, pause the video, try problems 2 through 5, and once you're done with that, we'll go through each of them and see what you got. All right. All right, so let's go ahead and look at the problems. So problem 2, this is what you should have got. Your equation should have been the absolute value of x minus 13.8 is less than or equal to 0.1. The red is your negatives, the negative case. The black is the positive case. You solve it out. You should have got an inequality of x is greater than or equal to 13.7, which is less than or equal to 13.9. So your acceptable weights are from 13.7 to 13.9. All right. So you're going to try 3 through 5. Just go ahead and pause the video and try them out. Try one more time, but we're going to keep going. Problem 3, this is what you should have got. The thermostat for your house. And it's actually a good problem to kind of see what I'm talking about when I say this stuff is really intuitive, and you've been doing it since you were kids. So we're told we have a thermostat at the house at 68 degrees Fahrenheit, and the actual temperature can vary as much as 2 degrees Fahrenheit. So it can be 2 degrees higher or 2 degrees lower, right? So that's where we get the 66 and 70 for the inequalities. This gives it all in black, but the right side is the negative, and this is the positive side. So this is the work. If you didn't get what I got, double check your work, see what you did wrong. But this is the answer. So on number 4, this is what you should have got here. And same things. Number 3, number 4, a little more intuitive to kind of understand what I was talking about. We're told Jason's bank account statement, his checking account, is usually at $320, but throughout the week it'll vary $80. So it'll be $80 higher or $80 lower. So it'll be up to 400 or down to 240, and that's where we get our inequality, and that's where we get our answer. So that means this balance will be anywhere from 240 to 400 at any given time because it will vary by $80 around that 320. And the last problem, this is another really intuitive one to really understand how these are done, what they're doing. This is what you should have got. So there's a speed limit on a road is 30 miles per hour. People will vary their speed by up to 5 miles per hour, so 5 miles faster or 5 miles slower. So that's where we get the inequality of x, or the driver's speed, being greater than or equal to 25, or less than, and less than or equal to 35. It'll be anywhere between that range. All right. And that's it for the video. Very short video. There's nothing else to do. This is the homework for the day. If you haven't done it, and after if you haven't watched this video yet, then that means you probably haven't taken the quiz yet. But this is the video, guys, and hopefully it was helpful. And that should wrap it up.